Hello, Fer.
Hi.
Bueno, en el primer video nos estuviste explicando un poco, la pregunta era cuál era la influencia de Newton no solo en las ciencias, sino en todo el periodo del iluminismo. Y para poder explicarnos eso, nos explicaste un poco lo que eran las artes liberales, ¿no? Y ahora ibas a explicarnos un poco más qué era la astronomía para poder relacionarla, según lo que entendí, para poder relacionarla con la física, matemáticas físicas, física
Okay, good.
matemática.
Yeah, I say all that because when I first studied Newton and even Galileo, but in the two new sciences, when I first studied Newton, it was very hard for me because I was really trying to figure out how it's about reality, and I resisted because I didn't quite get that it's a liberal art. Okay. So,
Wait. Sorry, ¿puedo preguntar?
yeah.
Yes. Que cuando estudiaste
In Thomas
Newton,
Aquinas College.
tenías que pensar mucho sobre qué era la realidad.
No, first of all, it was hard for me. And one of the reasons it was hard for me was because I was resisted because, so many people said, oh, well, you throw away philosophy, and this is now the new way of looking at the world, and this is the new and improved philosophy. And that didn't fit with my experience about reality. Philosophy is coming to know about natural reality. And secondly, I didn't quite agree, and I can talk about that later. If that were the case, I was supposed to take these laws of Newton at their face value, and it just didn't fit with my experience, that I want to talk about later.
Okay.
But in reading some more from Michael Agros, who's a teacher now at Thomas Aquinas College, and we were students together. He's a much better student than I. It helps me. I'm a little bit more aware about where Newton fits in, and the way Michael Agros does it, he puts him in as a liberal art. Okay. And so let's talk about that. Let's talk about astronomy. Okay, astronomy makes models in order to predict where the planets are going to be, and it's why? Because it's fun, and you get to learn. It sheds light on the way the planets are and things like that, and it's fun. We talked about that before. When you do that, you're just more free than the person who looks up the planets and go, I don't know. Okay, so it's just kind of a great thing to be able to knowledge for its own sake. That's kind of what it means to be liberal. Great. So let's have a quick review. I found these little things on the internet. Let's have a quick review on the difference between some of the main astronomers, just so we can talk about astronomy. So this is the Ptolemaic model, and all of these are models, where the Earth is at the center and the moon and all that stuff. And in order to do that, in order to really predict things, he had to come up with this. Part of his mathematical model is that there's epicycles. So these things move around the Earth, and not in his opinion, but in his model. Okay, and then some of them, as they're moving around, they move around a planet. Say the way this thing might move around this planet as the whole, and that's called an epicycle, as the epicycle itself moves around the Earth, according to his model. So the sun moves around, but this planet, I can't read it right now, what it's supposed to be, Jupiter, it has its epicycles, I guess little moons around Jupiter, I'm not sure, and they move around in little orbits as they're moving around the Jupiter. So those things are called epicycles. And it kind of explained things. It was pretty cool.
And in this model, the stars don't...
No, and not in any of these models, except maybe, in these first early models, the stars are fixed. Again, it's a model. Nobody was saying, I know that the stars are fixed. It's a model. Okay. What Ptolemy and Aristotle, talk about this in a bit, what they thought is that from the moon on, it was another world. This stuff was made out of eternal stuff. These things were called eternal bodies. And they didn't relate to the bodies like rocks and mud and trees that we have here on Earth. They were made of kryptonite. No, they were made of eternal stuff, okay? And we'll talk about that in a bit, okay? But then after Ptolemy, you got Copernicus, who put the sun at the center, okay? And in the Copernican model, there are epicycles as well, okay? See those little things? Those are epicycles. And the epicycle moves around the sun, okay? And that's not so crazy because we see that the moon moves around the Earth as the Earth moves around the sun. At least that's what we think. Okay, so the Copernican model puts the sun at the center and still has the fixed stars. Great. Then this is like a major breakthrough. This is Kepler. Kepler started to say, hey, there are physical laws on why these things are moving around the sun. So he put the sun being a massive ball of fire. In his model, he put the sun at the center, and then he tried to explain why these were moving in a way that we're doing. So he used what's called, what are these things called? I forget. Elliptical things. I forgot what they're called. They're not circles. They're ellipses, but they have a certain name for them. I don't remember what they're called. But let's go back to this one. So these things are moving as heavenly bodies, okay? Gods. And they move the way they do because they're gods, and gods have them move that way, according to this model. And according to this model, at least part of the reason why they move is because there's some physical interaction between them, between the sun and the planet specifically. And that's magnetism, according to Kepler. That there's this magnetism between the planet and the sun, and when it gets further away, it moves differently because the magnetic pull is not as strong. Okay? Well, watch this. When you get to Newton, between Kepler, I think it's between Kepler and Newton, but anyway, at some point you have Galileo, who developed the two new sciences to talk about laws of falling bodies, okay? Why specifically, why when you shoot a cannon, why it does what it does in order to land on the enemy and kill people on the side of the enemy. Much of what he does has to do with cannons and war. And that's okay. That's what they did in those days. Okay, so he started talking about mathematical physics. Well, actually, mathematical physics in its early stages starts with Archimedes. Okay, Archimedes was weighing bodies and predicting mathematical consequences of heaviness and stuff of bodies here on Earth. Mathematical mathematical laws discovered about weight and things like that, okay? But then you get to our good friend Sir Isaac Newton, and he was saying, you see, there's physical laws, the same physical laws. This is what's amazing. The same exact physical laws which govern the way planets move are the same physical laws that govern mathematical laws, okay? Mathematical laws that govern the way objects move here on Earth, okay? So there's this continuity between the principles of earthly movement and principles of heavenly movement. Now, Sir Isaac Newton emphasizes more than anything the heavenly bodies, but then he says these apply to physical bodies as well, or bodies here, okay? And by the way, it was he that in his book, The Mathematical Principles of Natural Philosophy, Mathematical Principles of Nature, constantly emphasizing that whatever's up there is the same stuff that's down here. And that's a big deal, okay? Because as I mentioned earlier, Aristotle and Ptolemy thought wrongly that that was heavenly stuff and this is earthly stuff, like in the strict sense of the word, like eternal and not changeable or something. Whereas down here, it's not eternal, at least cucarachas, they're not eternal. Thanks be to God. And changing, okay? So the things, cockroaches can move from here to there, cockroaches can die and stop being cockroaches, okay? Why did I say all that? Okay, so when you have that idea, when you get it in your mind that it's the same stuff, when you discover, they somehow discovered from Jupiter and things like that, look, it's the same stuff. I guess when they got asteroids that came to the Earth, they started to say, hey, this is the same basic material that my dog is made of, that these trees are made of, that rocks are made of. It's the same stuff. So I wonder if there are mathematical laws that shed light on the movement of bodies here on Earth, okay? So that's kind of cool. Now we have this overview of what astronomy is, and we included in that argument Sir Isaac Newton. So now let's talk about whether this thing that Sir Isaac Newton invented, so to speak, is, or developed or crystallized, that is to say, mathematical physics, if that is a liberal art, okay? So astronomy is a liberal art because it comes up with models, it's an art, and it's liberal because it sheds light on things that are worth knowing for their own sake. Remember, liberal arts, they'll help you make money because smart people make money. Liberal arts make you ability to get smart. But directly, they're concerned with knowledge for its own sake, okay? And when you do Newton, you're just concerned, and Ptolemy and Copernicus and Kepler, you're just concerned, if you do it for the right reasons, you're just concerned wow, look at the stars, how wonderful they are. Okay, so That's why astronomy is a liberal art. Now, mathematical physics is about it's about the stars and up there, but it's also about sound, light, magnetism. Okay, so it's about more than astronomy. So you don't want to say if classical physics, mathematical physics is a liberal art, you don't want to say, well, it's astronomy. I think, as Michael Agros would say, that would be reducing the whole to the part. It's actually the other way around. Now you could say, now that we've developed mathematical physics, or smart guys have developed it, and we can discover it, astronomy is a part of mathematical physics. So you could really, very intelligently say, let's call the quadrivium mathematics, discrete and continuous, continuous being Euclid, classic or mathematical physics, and music. Okay? As part of mathematical physics, you have the heavenly bodies and the earthly bodies. Now, what is it? Let's talk about this earthly body stuff. Let's see, do I want to say anything else on that? So, there's the argument on why mathematical physics is a liberal art. Okay? And now we can talk a little bit about what Newton is. And I want to take a little bit of a break here. We'll talk about what Newton is and how it's helps with philosophy maybe, but that it's not philosophy in the strict sense of the word. Okay? Thanks. Bye.